Working on an unfinished Victoria steamboat, Part 2. After speaking to Clevedon Steam, I find out exactly what the steam plant is. Examining the gas tank and removing the regulator, followed by fitting a new water gauge. Initially, when I first saw the plant, I said to the owner, "Oh, that's a Cheddar Models puffin steam plant." But when I looked at this engine with its very strange oscillating cylinder water pump, I realised that it was nothing like the Cheddar Models puffin that I have. It looks like a type of engine that's currently manufactured, I do believe, in Australia, and it's called a Clyde, C-L-Y-D-E. Apart from Blackgates Engineering, in the UK I use 3 other manufacturers for parts. Obviously Stuart Models, because I work on a lot of Stuart engines. Generally I buy gas burners and parts from Forest Classics, and for other small steam engine parts I use a company called Clevedon Steam. Their products are exceptionally good. Check out the website, the link is on screen at the moment. I decided to phone Jerry at Clevedon Steam and ask him what this engine is, because I couldn't make up my mind. It looks and feels like a Cheddar plant, and Jerry confirmed that yes, it is indeed a Cheddar steam plant. It's an early one. The engine with the strange water pump is a Mark I. I recognised the gas tank because I used to have one of these red gas tanks in a small steamboat many years ago. This gas tank is screwed to 2 pieces of wood. I don't know why, and I also don't know why it's been screwed to these 2 pieces of wood with screws that are too long. I also notice that it doesn't have the quick release knurled gas pipe nut. It has a standard union nut. It also has this gas regulator thing, and I'm not going to use this, mainly because it doesn't work anyway. Instead, I'm going to substitute a Clevedon Steam gas shut-off valve. I've used these for quite a long time on steamboat applications, because the last thing you want, if your model boat stops in the middle of the lake, is for the boiler to run dry, and then the subsequent Viking funeral effect. I'll show the fitting of this excellent radio-controlled gas valve in the next episode. If the boat should stop for any reason in the middle of the lake, you just throw a switch on your transmitter and it turns the gas off using a servo in the boat. This is a safety valve, and the sealing washer underneath it is cracked and split. I'm going to replace this. The O-ring at the top of the safety valve would appear to be a newer one. I remember from a couple of Cheddar Models plants that I had in the past, they have a piezoelectric igniter. You press the button and a spark occurs near the burner which lights the gas. To be honest, I do find these to be a little bit hit or miss. Sometimes they work, sometimes they don't. I would use a naked flame held over the chimney, either a gas lighter or a cigarette lighter. I removed the igniter to test it, and it does appear to work. But it's a bit erratic and the spark doesn't happen on every push. I'll refit it though, because it is part of the plant. It's time now to sort out the water gauge problem. I showed it in the last episode. Look at the state of this. It's corroded away to next to nothing. This clip shows the boiler bush where the top water gauge fitting goes. And this is perfectly serviceable. The threads on Cheddar Models and Stuart equipment are generally 32 threads per inch. Most of the time anyway. I take a 1/4x32 tap from my box of 1/4x32 taps and dies and try it for size in the hole. It's definitely the correct thread size. Unfortunately though, the boiler bush at the bottom of the boiler is a bit of a mess. It looks like part of the water gauge fitting is still in the hole. Normally to extract this I would use a stud extractor, but as soon as I poked it with a screwdriver, it had no substance whatsoever, and just crumbled, so all I need to do is clean up the threads in the boiler bush. I spray it with WD-40, and here, using a tap wrench fitted with a 1/4x32 threads per inch tap, I go through the boiler bush to clean up the thread. Then I check the thread using the original upper water gauge fitting. The cathodic corrosion caused by dissimilar metals can be eliminated by using Loctite 542. It's a thread sealant. It coats the threads, and because it stops them leaking, there is no cathodic corrosion and dezinkification of the fittings. You don't need to apply a lot, and you have to be careful with it because it removes paint very well. I'm fitting a Stuart water gauge, which appears to be identical to the original water gauge that was fitted, except of course this one's not corroded away. When you tighten water gauge fittings into boiler bushes, they do have to be tight, but not so tight that you strip the threads installing them. So if you're doing a job like this, try and use a firm but gentle approach. The piece of glass tube I'm going to use for the water gauge is a bit too long. It sticks out of the top. For that reason, I'm going to shorten it. It's really simple. All you need is the edge of a needle file and score all the way around the piece of glass tube. Then, using a cloth so you don't cut your fingers, just snap off the bit you don't want. I've shown the fitting of water gauges in so many videos, I decided to omit the part when I fit the glass in place. Suffice to say, it uses a couple of O-rings inside the nuts. And you must not over-tighten the nuts, otherwise when the boiler expands and contracts, it's likely to crack the glass. Very shortly I'm going to dismantle this boiler, remove it from the plant and perform a hydraulic test. I already know that it's okay, because I filled it with 60 pounds per square inch of compressed air and stood well back. And everything's fine. I knew it would be. This is a very well made boiler. I've adjusted the safety valve to make it blow off at about 40 psi, because oscillating cylinders don't like pressure much above 40 psi, as it tends to lift the cylinders away from the port faces. The safety valve is adjustable and it's down to the owner of the plant whether he wants to take it back up to 60 pounds per square inch. I can't issue a boiler certificate, but what I can do is when I test it I'll video it as a record of it having a hydraulic test. The best way to get a hydraulic test certificate is by joining either a model boat club or a model engineering society. Using Loctite 542 for thread sealing was recommended to me many years ago by a friend of mine, the late Randy Blackburn. I use it on any threads that require sealing. I don't like PTFE tape, it looks messy, but Loctite 542 is perfect. This is the main steam outlet union, coated in Loctite 542 and screwed into the top boiler bush. After allowing about half an hour for it to cure, I refitted the main steam pipe to the engine. All of this, of course, is a temporary measure. I'm not going to remove the water gauge, but I will have to disconnect the steam piping when I remove the engine and the boiler from the brass base plate. The engine's running a lot better. I'll leave it running to the end of this episode, but that's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.